So for this next video, we're going to talk about questions 11 through 16. This is where we've kind of switched gears into moles and molar masses and molecular empirical formulas. So number 11, the number of moles present in 1 mole of each substance. So you have 1 mole of NH3. Well, in NH3 there's a nitrogen and 3 hydrogens, which is why there would be 1 mole of nitrogen and 3 moles of hydrogen. So this is pretty easy. Number 12, what's the molar mass? How do you do a molar mass? Well, you have to have your periodic table out. You have to think about sig figs. You have to think about all those things. So let's just do this one real quick. We have 3 sodiums, which are 22.99 grams per mole, and you have 3 moles of sodium in that one compound. And you have aluminum. Aluminum is 26.98 grams per mole, but there's just 1 mole this time in the compound. And then there's 6 fluorines, so 6 times 19.00. And you'll notice that each of these happens to go to 2 decimal places. So after I multiply 3 times this and multiply 6 times 19, and I add it all together, I still end up with 2 decimal places. 13, determine the mass in grams. So this relies upon you doing some mole ratio conversions between moles and particles, or moles and mass, or just moles directly to mass, one or the other. So we had a couple of basic equivalencies. 1 mole of X is equal to Avogadro's number of particles. And 2 of these questions mention particles. There's molecules in both of those. And then 1 mole of X is equal to the molar mass of X, which we would get off of the periodic table. Each of these particles listed, it's nitrogen in every single one. So you should go to the periodic table and you say, well, what is 1 mole of nitrogen's mass? So nitrogen by itself is 14.007, so 2 moles of it would be 28.014 grams of nitrogen. But so here, let's do A, and then maybe we'll do D. Actually, the same question, just D is a single nitrogen molecule versus 3 times 10 to the 20th. But it's the same idea. You have 3.00 times 10 to the 20th nitrogen molecules, and you convert that to moles first using Avogadro's number. Molecules, nitrogen molecules, that is 1 mole nitrogen. And then we also know that the mass of 1 mole of nitrogen, as we just worked out, is 28.014 grams. So that converts it over, and that's where this answer comes from. It's just the conversions. With B, C, and E, it was already in moles, so I just immediately applied that equivalency to convert it over. I don't know where these 2 answers came from. Actually, I do. I just deleted some questions. And 14, arrange the following substances in order of increasing percent phosphorus. Well, how are you going to do the percent phosphorus? Well, you take the element in question and divide it by the total. So like with B, I'll just show you how I did B. I did phosphorus. Phosphorus is 30.974. It's the mass of phosphorus, and divided it by the total mass of phosphorus and 3 hydrogens. 30.974 plus 3 times 1.0079. And that's where I got that percentage of about 91.1%. And then I got to put those in order of increasing percentage. So I did each of these. I did phosphorus divided by the total, phosphorus divided by the total, 4 phosphoruses divided by the total. I actually just did 1 phosphorus divided by the total of these. I didn't worry about that 3 because I would have tripled everything equally. But you could have done P3 over N3P3Cl6 to give you that percentage. Would have been the same percentage whether you applied this 3 or not. I did not. So after figuring out the percentages, you can just put them in order. That's a pretty common type of multiple choice question where you have to do a lot of little math, not terrible math, just a lot of little math, and then put them in order using some logic. And then 15 and 16, calculate the mass percent cadmium in these compounds. That's pretty straightforward. It's just the cadmium that's in there divided by like the cadmium and the selenium. I should just find the molar masses and calculate the percentages. That's how I did those. Number 16, same idea. Calculate the percent composition of the pieces, the different polymers. Each one's the same. So you like this one here. There's 3 carbons. Carbon's 12.01 divided by the total. So 3 times 12.01 plus 4 times 1.007 plus 2 times 16. And that's where these percentages come from. And then after you've got the carbon here, for the second time to get the hydrogen, you just take the carbon out and you go, okay, well this time I'm going to do 4 times 1.007 on top. And just swap it in and out in your calculator. Make sure the calculator knows that all that stuff's in the parentheses at the bottom. Or go ahead and solve for this molar mass instead of leaving it all in the calculator at once. But basically it's the piece you're looking at, the carbon, the hydrogen, or the oxygen, divided by the total each time. All right, there's 11 through 16.